The National Electrical Code, or NEC, addresses requirements for service disconnects, particularly in scenarios involving multiple panels. When dealing with a 400 amp service split into two 200 amp main breaker panels located at different ends of a house, the question arises, should these disconnects be grouped together? There are varying opinions among electricians regarding this matter. One perspective, aligned with the NEC intent, emphasizes that overcurrent devices for a service disconnect must be grouped. The reasoning is that having main breakers in separate panels, situated at opposite ends of the house, arguably violates the code's underlying safety principles. Grouping disconnects ensures ease of access for both routine servicing and emergency situations, allowing for quick and safe power shut-off when needed. The contrasting viewpoint suggests that the NEC grouping requirement applies only to overcurrent devices within a single service disconnect. In this scenario, with two separate services, each having its own panel, the argument is made that the disconnects do not necessarily need to be grouped. Proponents of this approach may assert that having panels in different locations offers redundancy and enhanced reliability, potentially mitigating the impact of a localized electrical issue. However, several additional considerations should be factored into the decision-making process. Firstly, there are safety concerns. If an electrical fault occurs on one side of the house, accessing the main breaker in a distant panel could be time-consuming and potentially hazardous, especially in an emergency. Secondly, convenience plays a role. Grouping disconnects simplifies the process for homeowners when they need to operate the main breakers, whether for planned maintenance, electrical work, or unexpected events. Thirdly, maintenance is a key factor. Group disconnects streamline maintenance and troubleshooting activities, allowing electricians to quickly identify and address any electrical issues that may arise. Considering these factors, a consensus exists among many electrical professionals that grouping disconnects in a single panel, ideally in a central and easily accessible location, aligns best with NEC safety objectives, as well as promoting convenience and simplifying maintenance procedures. It's important to understand the potential implications of different configurations, considering both code compliance and practical considerations. The purpose of the NEC is to provide a standardized set of guidelines for electrical installations aimed at ensuring safety and preventing electrical hazards. While the NEC provides a framework, interpretations and local amendments can vary, emphasizing the importance of consulting with qualified electrical professionals who are familiar with local codes and regulations. When planning or modifying an electrical service, a thorough assessment of the property's layout, electrical load requirements, and potential safety concerns is essential. This assessment should take into account the accessibility of disconnects, the potential for future expansion, and the overall reliability of the electrical system. For example, consider a situation where a homeowner plans to add a significant electrical load, such as an electric vehicle charging station or a large appliance. In such cases, the existing electrical service may need to be upgraded to accommodate the increased demand. When upgrading the service, it's an opportune time to address any existing code violations or potential safety hazards, including the configuration of service disconnect. Another relevant factor is the type of overcurrent protection used in the electrical panels. Circuit breakers are commonly used to protect circuits from overloads and short circuits. These devices are designed to trip and interrupt the flow of electricity when a fault is detected, preventing damage to wiring and equipment. The NEC specifies requirements for the selection, installation, and protection of circuit breakers, ensuring that they are properly rated for the circuits they protect. When evaluating the configuration of service disconnects, it's important to consider the coordination of overcurrent protection devices. This involves ensuring that the circuit breakers closest to the fault trip first, minimizing the impact on other circuits and equipment. Proper coordination can enhance the reliability and safety of the electrical system. In addition to the NEC, other standards and guidelines may be relevant to electrical installations, such as those published by the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. These organizations provide valuable resources and best practices for electrical design, installation, and maintenance. Furthermore, it's essential to be aware of any local amendments or interpretations of the NEC. Local authorities having jurisdiction may adopt additional requirements or modify existing ones to address specific local conditions or concerns. Consulting with local electrical inspectors can help ensure compliance with all applicable codes and regulations. To summarize, the question of whether to group service disconnects in a 400 amp service with two 200 amp panels involves considering NEC requirements, safety concerns, convenience, and maintenance. While differing opinions exist, a consensus favors grouping disconnects in a central, accessible location to enhance safety and simplify operations. Understanding the potential implications of different configurations, consulting with qualified electrical professionals, and adhering to all applicable codes and regulations are crucial for ensuring a safe and reliable electrical installation. The NEC, specifically Article 230, covers service entrances. This article provides detailed requirements for service conductors, service equipment, and disconnecting means. Section 230.71, for example, addresses the maximum number of disconnects permitted for a service. It generally allows for up to 6 switches or circuit breakers to serve as the disconnecting means for a service. However, local codes or utility requirements may impose stricter limitations. Section 230.72 outlines the requirements for grouping service disconnects. It generally requires that service disconnects be grouped and readily accessible. This requirement aims to ensure that all disconnecting means for a service can be quickly and easily located in case of an emergency. The intent is to prevent confusion and delays in shutting off power to a building or structure. The NEC also addresses the rating of service disconnects. Section 230.82 specifies that the disconnecting means for a service must be rated to interrupt the available fault current at the service entrance. This requirement is critical for ensuring that the disconnects can safely interrupt short circuits or ground faults without failing or causing further damage. In addition to the NEC requirements, utility companies often have their own specifications for service entrances and disconnecting means. These specifications may include requirements for the type of equipment used, the location of the service entrance, and the grounding and bonding of the electrical system. It's essential to consult with the local utility company to ensure that the electrical service complies with their requirement. Grounding and bonding are also crucial aspects of electrical safety. The NEC Article 250 provides detailed requirements for grounding and bonding electrical systems. Grounding helps to stabilize voltage to earth and provide a path for fault current to flow back to the source, allowing overcurrent protection devices to operate. Bonding ensures that all metal parts of an electrical system are electrically connected, minimizing the risk of electric shock. The size of grounding and bonding conductors is determined by the size of the service entrance conductors. The NEC provides tables that specify the appropriate conductor sizes for various service ratings. Proper grounding and bonding are essential for preventing electrical hazards and ensuring the safety of occupants. In addition to the technical requirements, there are also practical considerations to keep in mind when designing and installing an electrical service. The location of the service entrance should be carefully chosen to provide easy access for maintenance and repairs. The service equipment should be protected from physical damage and environmental conditions. The wiring should be neatly installed and properly supported. A well-designed and properly installed electrical service will provide reliable power for years to come. The NEC is updated every 3 years, so it's important to stay current with the latest requirements. Changes to the code can impact the design and installation of electrical systems. Continuing education and professional development are essential for electrical professionals to stay informed about the latest codes and standards. When in doubt, it's always best to consult with a qualified electrical inspector or engineer to ensure that the electrical service complies with all applicable requirements. Choosing the right location for your service disconnects involves several key considerations. Firstly, accessibility is paramount. The disconnect should be readily accessible to both homeowners and emergency personnel in case of a fault or other electrical issue. Secondly, the location should be dry and protected from the elements to prevent corrosion or damage to the equipment. Thirdly, the disconnects should be located in an area where they will not be obstructed by furniture or other objects. Fourthly, ensure enough working space around the disconnects, as per NEC requirements, to allow for safe operation and maintenance. Common locations for service disconnects include the garage, the basement, or an exterior wall near the service entrance. However, the specific location will depend on the layout of the house and the location of the service entrance. In some cases, it may be necessary to install a remote disconnect if the main disconnect is not readily accessible. Remote disconnects must comply with all applicable NEC requirements. One frequently asked question involves the use of surge protection devices, or SPDs. SPD are designed to protect electrical equipment from voltage surges, such as those caused by lightning strikes or power grid switching. SPD are typically installed at the service entrance or at individual electrical panels. The NEC requires SPD in certain applications, such as in dwelling units and critical facilities. SPD can significantly reduce the risk of damage to electronic equipment caused by voltage surges. When selecting an SPD, it's important to choose one that is properly rated for the electrical system and that complies with all applicable standards. Another important consideration is the labeling of electrical panels. The NEC requires that all electrical panels be clearly labeled to identify the circuits they serve. The label should be accurate and up to date. This will help homeowners and electricians quickly identify the correct circuit in case of an emergency or for maintenance purposes. The labeling should be done in a professional manner using a permanent marker or label maker. A well-labeled electrical panel can save time and prevent accidents. When working with electrical systems, it's essential to follow all safety precautions. Always turn off the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it's best to hire a qualified electrician. Electricity can be dangerous, and it's important to take all necessary precautions to prevent accidents. Common mistakes when installing electrical services include using undersized conductors, failing to properly ground and bond the system, and neglecting to follow NEC requirements. These mistakes can lead to electrical hazards, such as overheating, electric shock, and fire. It's essential to carefully review the NEC and follow all instructions when installing electrical services. If you're unsure about any aspect of the installation, consult with a qualified electrician. Regular maintenance of electrical systems is crucial for ensuring the safety and reliability. This includes inspecting wiring for damage, testing circuit breakers, and tightening connections. Electrical panels should be kept clean and free of debris. Regular maintenance can help identify potential problems before they become serious hazards. It's also important to have electrical systems inspected periodically by a qualified electrician. An inspection can help identify hidden problems and ensure that the system is up to code. In conclusion, the installation and maintenance of electrical services require careful planning, attention to detail, and adherence to all applicable codes and regulations. By following these guidelines, you can ensure the safety and reliability of your electrical system. Remember to consult with qualified professionals when needed and to prioritize safety at all times. When dealing with a 400 amp service, understanding the specific requirements for conductor sizing is paramount. The NEC provides tables that dictate the minimum ampacity of conductors based on the load they will serve. For a 400 amp service, you would typically need conductors that are rated for at least 400 amps. However, directing factors may apply depending on the installation conditions, such as the number of conductors in a conduit or the ambient temperature. It's crucial to consult the NEC tables and apply any necessary directing factors to ensure that the conductors are adequately sized. Using undersized conductors can lead to overheating and potentially cause a fire. The type of conductor insulation also plays a role in determining its ampacity. Different types of insulation have different temperature ratings. Conductors with higher temperature ratings can carry more current without overheating. Common types of conductor insulation include THHN, THWN, and XHHW. Each type has its own specific properties and applications. When selecting conductors, it's important to choose the right type for the environment in which they will be installed. The NEC also specifies requirements for the overcurrent protection of conductors. The overcurrent protection device, such as a circuit breaker or fuse, must be sized to protect the conductors from overload. The size of the overcurrent protection device should not exceed the ampacity of the conductors. This ensures that the conductors will be protected from damage in the event of an overload. Proper coordination of overcurrent protection devices is essential for ensuring the safety and reliability of the electrical system. Ground fault protection is another important safety feature to consider. Ground fault protection devices, or GFP devices, are designed to detect ground faults and quickly interrupt the flow of electricity. Ground faults can occur when current leaks from a circuit to ground. This can create a shock hazard and potentially cause a fire. The NEC requires GFP devices in certain applications, such as in bathrooms and kitchens. GFP devices can significantly reduce the risk of electric shock. Arc fault circuit interrupters, or SIs, are another type of safety device that is designed to protect against electrical fires. SIs detect arc faults, which are dangerous electrical arcs that can occur in damaged or worn wiring. Arc faults can generate high temperatures and potentially ignite nearby materials. The NEC requires SIs in certain areas of the home, such as bedrooms. SIs can significantly reduce the risk of electrical fires. When installing a 400 amp service, it's important to consider the voltage drop in the conductors. Voltage drop is the decrease in voltage that occurs as current flows through a conductor. Excessive voltage drop can cause equipment to malfunction and reduce the efficiency of the electrical system. The NEC provides guidelines for limiting voltage drop in electrical circuits. To minimize voltage drop, it's important to use conductors that are large enough for the length of the circuit and the amount of current it will carry. In addition to conductor sizing, the type of raceway used to enclose the conductors can also affect their ampacity. A raceway is a conduit or other enclosure that protects the conductors from physical damage and environmental conditions. Different types of raceways have different heat dissipation characteristics. Conductors installed in enclosed raceways may need to be aerated to account for the reduced heat dissipation. The NEC provides tables that specify the derating factors for conductors installed in various types of raceways. When planning a 400 amp service, it's important to consider the potential for future expansion. If you anticipate adding more electrical load in the future, it's a good idea to install conductors and equipment that are sized to accommodate the increased demand. This will save you time and money in the long run. The NEC also provides requirements for the accessibility of electrical equipment. Electrical equipment must be readily accessible for maintenance and repairs. This means that the equipment should not be blocked by furniture or other objects. The NEC also specifies minimum working clearances around electrical equipment. These clearances are designed to provide adequate space for electricians to safely work on the equipment. Before starting any electrical work, it's important to obtain the necessary permits from the local building department. Permits are required for most electrical installations to ensure that the work is done safely and in accordance with the NEC. The building department will typically inspect the electrical work to verify that it meets the code requirement. In summary, installing a 400 amp service requires careful planning, attention to detail, and adherence to all applicable codes and regulations. It's important to consult with qualified electrical professionals when needed and to prioritize safety at all times.